Hello and welcome everybody. In the last tutorial, we built our first microservice for drone pizza delivery application. That microservice was called by the name Command Center. In this tutorial, we'll be building the second microservice for the application, and this microservice will be called Process Center microservice. So the first microservice was actually taking the pizza orders, and this second microservice will communicate with the first microservice in a synchronous manner, as we'll see soon. And I am a Microsoft .NET developer. I have been for the last 15 years, and I've worked in many industries as senior consultant and developer, and also I have taught at the universities and polytechnics in New Zealand, in Christchurch and Auckland, and I know what I am talking about. So let's, without any further ado, let's go and see what is in the offering. So this is what will be covered. Create a process center microservice using ASP.NET 6 and clean architecture like we did for the command center microservice in the previous part, or part 2, and we'll be talking about building data transfer objects in a similar manner to the previous tutorial, and we'll be creating the MongoDB connection string, configuration, repository, and setting. And additionally, we'll actually demonstrate the use of the HTTPClient class to communicate with command center microservice. So there we are. Let's switch over to the Visual Studio and start building our project. So I have opened the Visual Studio 2022, and let's create a new project. So we have got ASP.NET Core API as the recently used template. Okay, and then we'll create next. We'll click next and name this project Process Center. Process Center, and click on next with the default location that I have already created there, and then click on next, and then again next with the default as ASP.NET 6 long-term support, and configure for HTTPS and rest of the checkboxes ticked as the default, okay, without changing them, and click on create. It's going to create the application. Now next we'll create a folder entity on the root of the project. So right click, add new folder, entity. So as before in the command center application in the previous part, we'll create the three classes, that is IEntity, IRepository, and the third one is process. This time it is process, okay, because it's a process center application. So accordingly, I will create these three classes. If you want, you can please follow along, and I will describe each and every step of the process. Okay, so add class. Now here it is. This is actually an interface. So this is not class, interface. Okay, and I'll rename this interface as. One way of doing it was to rename it in the first place, and or otherwise let it be created with the default interface.cs and then change the interface to IEntity. Okay, yes, public interface IEntity. Okay, that's fine. So namespace process center.entity and public interface is created, and within this entity IEntity interface, it has got just one method get ID gets it. Tap to accept. All right, save it, and then I will create the IRepository class. And this is also an interface, so I will go for interface, and this time I will change the name of the interface in the name itself. So it is IRepository of T, where T is the generic T class, generic type, IRepository T. Let me see if you can add it like that. All right, now it doesn't take the name with a T attached to it, generic type, so let it be IRepository and click on add, and then I will change this public interface IRepository of T, and what is T? Where T goes to, T is a class, and what is this class? This is actually not the class, this is an IEntity interface. IEntity, okay, that's fine. So now a few members of this interface IRepository it's a CRUD application interface, so it creates the contracts for making all the methods, creating all the methods in the repository class. So what are those members? So first one is task. Excuse my typing. Create async T entity, tap to accept. Yeah, it's pretty brilliant. So task update entity with T entity, that's fine. So I will keep this a bit down in the hierarchy, and before that I will complete the other tasks. Task of I read-only collection of, what is read-only collection on type T, generic type T, and we'll call this get all async. So asynchronous call, it's an asynchronous method which returns a task which is of type read, I read only collection, okay, of generic type T, which is IEntity interface. Okay, T belongs to, T implements the IEntity interface. Okay, so another one is, I'll just copy this part, paste, and then get all async. This is the overload of this get all async method. So first one is expression function of T and Boolean filter. All right, so get the list asynchronously, and I'm passing an expression with function of T and Boolean. So what does it do? So as before, the use of func delegate is for filtering of records from the database. For example, expression func T on t comma bool filter means we can provide a function that accepts a t type of parameter and returns a bool value. We already know that t is of IEntity type. Okay. Then the fourth method is it's also returning a task of t, and it is called getAsync. And the inside is, the same arguments are passed on to getAsync method. So expression function t bool filter. So this is exactly the same. The only thing is it is just getting one item as opposed to the get all async method, which is returning the list of all the items. Okay, and it's just returning it's not a collection, but it is returning a type t, which is IEntity. Okay, so get async expression function t bool filter. Okay, and then this also works for, it's a function that accepts the type parameter t and returns a bool value. Okay, and then finally it's the remove async. Delete async, or rather remove async. You can keep it delete async, but since I am following that blog, then I am going to rename this in keeping with the style that we have followed, naming convention for the methods we followed for the command center application. And here the difference is that I have to pass a GUID ID, a GUID, which is ID. All right, let's create the process class now. So add class. This is the model for this application, because this is process center, so public class process, and this is also implementing the IEntity interface. Okay, I don't worry about these this red squiggly line, because it says the process does not implement interface member. So I am going to implement anyway. So first is GUID ID again. Let me copy and paste it over many all the properties, and then I will start changing them. Okay, it's one of the approach you can do. So public GUID ID and then public GUID order ID. This will be order ID, get set, and then so order ID is from the this order from the command center. This is you can say it's equivalent to like a foreign key in the process table from the order table. So public GUID drone ID again an ID, because this is a drone application, so drone ID is important here. And then public, this is status, status of the process, status of the order, I would guess, public string status, and then date time offset. Alright, so this is the process class. So let's go over it a little bit. So this ID is the process ID of the order. Its value will be of get type, and order ID, as I told you, it will be the fetched from the first microservice, the command center, okay, which is actually the order, where the order is placed. And then drone ID is the ID of the drone which will be shipping the order, and status, as I told, that it will be the status of the pizza delivery of an order. It can have 3 values: submitted, processing, and completed. And acquired date is the date time when the order was provided to the second microservice. Now we will create an infrastructure folder on the root directory. So add new folder, infrastructure folder, and to this we'll add a DTOs class. Public class DTOs, okay, and then to this DTO class we'll add a few records, okay, record type, and this DTOs layer, these DTOs are used to pass data between layers and does not contain any business logic, okay. So let us see them. So I am supplying the GIDs first, drone ID, and then order ID. Because this is known as grant order DTO, so it has to have that order ID also passed to it, and then status, which is of type strings. And the second one will be public record process DTO. And to this process DTO record, we'll pass the order ID, and then everything that was there in the order model is address and quantity. So address was of string type, quantity is of type int, and then status process ID. Then comes the process parameters, process model properties, string status, and then get process ID. Let me wrap it in the next line. So this was process ID, and then after this will be drone ID, and then date time offset type acquired date. So we've got two records with us. One is the grant order DTO and the process DTO. The name is, I think, self-explanatory. What they should contain, what the parameters, what are the things that is passed to the records. So they are not methods, so it's not parameter. Wrong to say parameters, but it is just like a record that needs some inputs. So these are the inputs, and then public record order DTO. That's it. So order DTO contains everything related to the order model, address and quantity. And this is a process DTO. It takes the maximum number of inputs. Okay, like order ID, and then it takes the order address and quantity, and then its status from the process model, and then process ID, and then drone ID and acquired date. And this is grant order DTO, which contains the drone ID, order ID, and status. Okay, so this DTOs will be used to pass data from one layer to the other, and it will not contain any business logic, as we will see soon. And we have already seen that in command center. So I highly recommend you to look into the first part on the command center microservice, which will be there in the description of this YouTube video, and also as cards. Okay. Next is the turn of the extension class, extensions.cs on the infrastructure folder, like we did for the command center. So new class, extensions. So public, this was a static class there also, so it will be a static class here, public static class extensions, and this should contain public static method, public static process DTO as DTO. A bit strange name, but I am just following the procedure given in that block. So let's see what these squiggly lines are for. So this is telling some potential fixes process DTO could not be found. It's asking for this library using static process center.infrastructure.dtos to include the DTOs. Okay, and then there is another library that I have to use, or rather another using statement. It's not library strictly, so using, I have to bring process entity folder. So using process center dot entity folder. So these are the two things I needed to bring by using the using statement. Okay, so this is the DTOs file or DTOs class. So I have to bring in process center.infrastructure.dtos and process center.entity folder, because I need to use this process.cs. Okay, so let's see. So back to extension class, and let me complete this by copying from my clipboard. So this is the completed process DTO static method, which is named as DTO and which returns a process DTO. Okay, so with these properties, process.process ID, process.order ID, then address, and then passed in quantity, then process.status, process.id, and process.drone ID, and process.acquired it finally. Like what we did when creating our first microservice, these things will remain the same. So let's open the appsettings.json file. So where is it? So this is where it is, and we'll change some settings like we did for the command center microservice, and these settings are just above allowed host. It has got service settings and MongoDB settings. So I have got it on my clipboard, and I just paste it below this comma. So service settings, service name, process, and MongoDB settings with host and port. Port is always 27017. Okay, and then save as. And here the only difference is that we have provided service name as process. So for this microservice, a database by the name of process will be created on MongoDB. So another database which was created for command center was order database was created from the command center. Likewise, it will create a process database. Now we create the necessary classes that will deal with these MongoDB values. So on this step, the things will just remain the same like the first microservice. So we'll create a setting folder on the root of the project. So this is the root of the project. Add new folder. Call this setting. And within this setting folder, I will create MongoDB settings.cs and service settings.cs, service settings class and MongoDB settings class. So let's see. So public class MongoDB settings. So again, it has got two public properties in host and port, and the connection string is made with host and port with enclosed in curly braces so that the value will be actually got evaluated. All right, and there's a semicolon over there. Then save this file. And similarly, the code of service setting class. Let me create the service settings class. So it has got just a public property. service name. Okay. So before running any further, before coding any further, I just quickly built up the project to see that it succeeded. So it would have come up with some runtime error. So we have taken care of everything. Now next is to install the MongoDB.driver, which is before we create the repository, which will directly communicate with the MongoDB database, we'll require to have this driver. Okay, so we'll go to the NuGet package, right click, manage NuGet packages, and look for browse for MongoDB.driver and install this. Click on OK, click on I accept, and you can see that in the installed packages MongoDB.driver is already available. Okay, now next we'll create a new folder called MongoDB on the root of the project. So we'll create, right click, add new folder, and we'll add two classes. One is the MongoRepository class and another is the extensions class. Extensions, and we'll start writing code on this two classes. So this MongoRepository class it takes on a generic T type which implements IRepository. IRepository of T, where T derives from T implements IEntity class, IEntity interface. Okay, and to get IRepository T, okay, of course we'll implement it. So don't need to bring the members in a template or just the shell. So I have now completed this repository class. This is MongoRepository class. Just for the sake of brevity and save time, I've copied it from my clipboard, and it is the same exactly what we did in the command centers, but I will explain. This is actually implementing the IRepository interface, where T is implementing the IEntity. So it is basically, if you look into IRepository class, right click and go to definition. So IRepository has got create async. So if you keep both the IRepository interface and the MongoRepository class side by side in new vertical tab group, you can just compare that it is implementing all the members of this IRepository interface. So let me get this a little bit of space over here. So this is using the iRead-only collection get all async, and then get all async with expression function t bool and passed into it, and then get async, and then on top it's create async. Create async is here. Yes, create async with T entity, T type. So all of these signatures in this interface are getting implemented in the MongoRepository from the IRepository interface. Okay, so just close this. Yes, save. Okay, right, and then let's write the code for the extensions class. Public static class extensions, and here also I will put the code from my clipboard to save lots of time in typing, which I've already seen in the previous tutorial on the first part, command center. So using process.entity, using process center.entity, and using process center.settings. Okay, it has to plot to get all these squiggly lines off and then save all the files. Let's quickly again run a Control Shift B for hotkey combination for the build. So build 1 succeeded, 0 failed, 0 up to date. So its build is succeeded. So far so good. Now we need to register the methods given on the extensions class in the startup class. Okay, and since we are using ASP.NET Core 6 or ASP.NET 6, we don't have any startup class here. We are using the minimal API method of creating the application, so we'll do the necessary changes in the program class. And what we have done is we have added the add Mongo service, add Mongo dot add Mongo repository for process class, and we'll create a collection known as process items. Okay, so what this add Mongo repository does is add Mongo repository. So quickly go to the definition. So add Mongo repository is from here, extensions class. So it adds the Mongo repository after passing a parameter of iService collection and a collection name and a string collection name. Okay, and then it returns a new Mongo repository T with a database and collection name. Okay, and it returns the service. The collection name is passed to it and it returns the services. Okay, so it is adding to the service collection by add singleton. Right, so back to our program file, the back button, and now we have to also configure the Swagger, because I'll be extensively using the Swagger. So like before, builder.services.add Swagger gen. Here I will create a lambda expression C goes to then there's a pair of curly braces and C dot Swagger doc. Here is a version, so it tells you all the things that it would like inside the as a parameters string, name string, and then Microsoft.openapi.models OpenAPI info. So let's first thing is the version, say v1 within quotes, double quotes, version 1. Let's suppose this is version 1, and then new OpenAPI info. Okay, Microsoft.openapi.models.opi info. So either you take this or make the fully qualified name. So I will take this as a using statement. Microsoft.openapi.models. So new, I can now safely write API info OpenAPI info actually, and then curly braces, then first is title, process center, let's say version 1, and then semicolon to terminate the code. Okay, and then save it, Control S. So we'll have to come back and revisit program file again to make some more changes when we add the time, this poly and the circuit breaker for error handling. That will be in the next part, but obviously that I will cover in this part itself, but in the next section you can say. Now is the time to create the HTTPClient class to communicate with the first microservice. Now this second microservice or the process center microservice should be able to communicate with the first microservice. This we can do with the HTTPClient class. So we'll have to create a new folder called client on the root of the project and add a new class called orderclient.cs. So let's do it. So process center, add new folder, call it client. So on this client root, I will create a new class called orderClient. So why it is called orderClient? Because it is client to the order class, which is the command microservice. Right. And this class will make web API request to the order center microservice or command center microservice and uses HTTP client class for doing so. The code, let us write the code. So, okay. So public class order client. So I'll create the private read-only property of type HTTP client. Let's take the underscore away, and then a constructor this is creating all sorts of problem, this IntelliSense cancellation token registration. All right, so public order client, and here we'll inject through the dependency injection HTTP client, and this dot HTTP client is assigned HTTP client. This is the dependency injection. By dependency we are injecting the HTTP client class, right? And then let's start writing the method. So public async task, and this will be again a read-only collection on order DTO. This squiggly line, it is telling me to include using static process center dot infrastructure dot DTOs. So order DTO, and name this method get order async. So variable items, so items gets its value from HTTP client injected dot, I'll call get from JSON async method. So asynchronously it will get the items from the client and put it in the JSON form. So get from JSON async, the task object representing the asynchronous operation. It sends a GET request to the specified URI and returns the value that results from deserializing the response body as JSON in an asynchronous manner or asynchronous operation. And here it is operating on the order root. So /order. So /order means whatever is the localhost :port, then it is appended with /order. Okay. So and then return items. Now here you can see that this items is of which type? IRead-only collection on order DTO. Okay, so this is returning the correct type as required by this asynchronous method get orders async. All right. So here is a green squiggly line, item may be null here. So you just ignore this. This is a warning. Now the call to the first microservice or the command center or the order microservice is met inside this get order async. Now /order, again, as I said just now, it was the root to the web API we created in the first tutorial. Now next I will have to register the order client in the program file. Ideally, in the earlier version, it was to be registered in the startup class, but now we are using minimal API and program.cs is the only class which has the function of startup class. So we'll write it there. register it there. So once again, here in the program class, below this line of code, we'll add another line. Builder dot services dot, this time it did add HTTP client, and this is, we'll call this order client. Order client, this is the order client class within the process center dot client folder. So this is the order client class. Okay, right. So, and then the lambda operator, say A, you can write anything, B, C, D, E, anything, A to X, A to Z. So A goes to A dot this has to be within a pair of braces, pair of curly braces. Just indent it a bit. First put a semicolon to terminate this. So A dot, now base address, we'll call the base address. So base address is equal to now I have to follow it with localhost colon port. Excuse my typing. And how do I get the correct port number? Do I get this localhost? Now this is for the localhost will be the command center microservice, because it has to communicate with the command center or the order microservice. So let's get the order microservice and note down its port that it should actually try to connect to. So I have opened the launch settings.json file from for the command center. Okay. So now I have opened the launch settings.json. You can see from the command center project, and I've noted down this application URL for launch URL is Swagger, and application URL with localhost of 7196 with the HTTPS socket layer, and put it down over here as a new URI for the base address. Okay. So the next step will be to create the web API controller for the process center. We shall now create a web API controller called process controller inside the controllers folder. It will have methods that will insert data to the MongoDB database and also make asynchronous call to the first microservice, that is the command center microservice or the order microservice, to get order details. The data will be stored in a MongoDB database like before, and the MongoDB will run from a Docker container. So in the last tutorial, in the previous part or part 2, I have explained how to run MongoDB database on a Docker container, and so you have to watch that video first, and so that you can make sure that you have followed that part correctly. And everything was explained in great detail and very clearly. So let's create the process controller inside the controllers folder. Okay, so this is the controllers folder. So I will let the weather forecast controller.cs remain there, because if I delete that, I have to remove many dependencies. So I don't want to mess it all up. Okay, so it doesn't matter anyway. So right click controllers folder and add controller. Sorry, my computer is extremely slow. This is a PC, old PC for 5 years old, but anyway, it's serving me well. So add So I've clicked on right click on controllers folder and clicked on add controller. So it is going to add a controller, and I will come back after it successfully adds the controller and explain the further details. So after a long delay, it has come up with this new add new scaffolded item folder, and it is already highlighted the MVC controller empty, and I will go for empty controller and I will put my own code. Okay, and here I am not using entity framework, right, because that is for SQL, and I'm using MongoDB as the backend, right? So click on add. Again, there might be some long pause before it creates the controller, so I will pause here and come back. So it has finally come up with this add new item process center, and it has already named a home controller which is already there, so I will get rid of this and put my controller as process controller. So process controller, and it will be a C# class. So it will create the process controller for me. So now it has come up with the controller, process controller, which is deriving from controller. So I will actually make it, because this is not an MVC controller, and it should be actually derivable from controller base rather than controller. You can also derive it from controller, but doesn't matter, because I don't want any. It is not going to have any GUI functionality. So controller base is a lightweight. A base class for an MVC controller without view support. Okay, so let's see what is the controller class. So for the controller, a base class for an MVC controller with view support, but I don't want any view support. So let's create a view. Controller base class as the base class. All right, and I'll get rid of this index action method, the default one, and I will start writing. So now above this public class, process controller class, I'll have to decorate it with a couple of attributes. The first attribute is going to be API controller. So API controller. So this API controller, it's when decorated on an assembly, all controllers in the assembly will be treated as controllers with API behavior. Okay. So you can see more information in the API controllers attribute. Okay. Now another attribute will be the route attribute. So the route name is process. So /process will give you the correct navigation path. So let's see what the route, it specifies an attribute route on a controller, right? So having come to this part, let's start writing the code of this process controller class. So read-only property of IRepository on process type repository. Not the logger class. I don't need the logger class over here. So let me get rid of this part. This will be an order client. Okay. So this is the notation, correct notation that this is the camel notation I am following. Okay. And then there is a constructor for dependency injection. So public process controller, this is a constructor, parameterless constructor, but I will inject these two IRepository type of process and order client type as dependency injection. So basically I will inject the dependency. I hope you all know what is a dependency injection, and if you don't know, then I can refer to some good articles to get you going, and I could put it in the description or on demand as a comment. So order client, see how AI driven and intelligent has become Visual Studio 2022. So it actually gives you a quite accurate suggestion on many occasions for completing the code quickly, and just tab it HTTP get. See, this part is also correct. Get verb. So this, let's start writing. It saves a lot of typing time, my dear. I'm very thankful to Visual Studio. Public task, with public async task, action result type, and action result type on it will be an IEnumerable I, and IEnumerable on process DTO. Now this squiggly line is because I have to include a library using static process center .infrastructure.dtos. Okay, so this is added, and this will take care of the squiggly line, and then this method is called get async. And I will have to supply the drone ID, which is a GUID. And I'll soon explain what this get HTTP get verb, what this get async method is going to do. Our basic purpose is, because we want to show the communication between these two microservices. So the second microservice, which is a client, will talk to the first microservice and request it for some data, which will be returned back as a response from the command microservice or command center or the order microservice, so that we know that we have been able to successfully get the communication going from one microservice to another microservice. And this is the synchronous communication, not the asynchronous communication, although the methods are async. So now let's start writing this method. Complete this method as drone ID is empty. Then we shall return a bad request. Not exactly, not found, but we can put it as a bad request. Bad request. This time it's not correct. I don't want repository.get all async, but I want something like order client dot get order async. Get orders async. So I hope this part is clear. So on a variable var type orders, I am awaiting on the order client, which is operated with the, which is calling the get orders async to get the order. Okay, and what was get orders async? Get orders async was here. Quickly, if you want to see, go to definition. So get orders async. So there I was awaiting on the HTTP client was calling get from JSON async and passing the I read only collection type order DTO. Okay, on this route order. So what this get from JSON async was doing, which we have already seen. Okay, and then var orders and then var process entities. So what does the process entities variable is assigned to? It calls the get all async method on the repository object, which is passed through the dependency injection, and it looks for a lambda expression where a.drone id equals the supplied drone id. Okay, so this drone id was supplied to this method get async method, and if the lambda operator dot drone id is equal to the supplied drone id, then it will be stored in the process entities. This is the filter, the condition. Okay, and then another variable var common entities. Now I will use this process entities and I will create a join, just like a Microsoft SQL join. It's also joining. So process entities dot join. So what does it accept? This join method. It's an extension method, and it has got a few parameters. It can take process, t inner, t key, t result. So anyway, it will be clear as we go along. So this is the orders. So what is the orders over here? It is the local variable order. Okay, this is this variable which we got from calling the get orders async on the order client. Okay, so this is the orders we got, and then call this lambda operator a goes to a dot order id. Or a implies that a dot order id. So it is joining the two tables. So orders, a goes to a dot order id. Let's first complete this and then we'll do some explanation. So because it's a join between the two tables, so A is the order table, you can say in the order database, and B is the other table, okay, and the process, I guess. So B.id, A goes to A.order ID, B goes to B.id. A comma B goes to new order ID. A comma B is a function having two parameters A and B, where A and B, A comma B goes to new, is a new type of expression notation. So order ID B.id. So this is, I think, giving some idea or insight into those who are accustomed with joining the SQL tables, inner join, outer join, etc. Okay, left join, right join. So new order ID equals B.id. Further, B.address, B.quantity. So it straight away gives you an idea, if you have recalled your previous lecture on the command center, that B is standing for this address quantity belong to the order table, okay, or order collection rather say. It's wrong to say because we are using MongoDB. All right, so this is order collection. So B.address, B.quantity. Similarly, now as we go along, this will be clear what I'm trying to do, but I'll still explain. Process ID equals, now we are coming to the process collection. ID equals A.id A.drone ID, A.status, A.acquired date. So obviously this is from the process model. So next is a list of process DTO. Which we'll call as process DTO list simply. So we'll initialize a process DTO list. Alright, so we initialized a list of process DTO record, which is the record. Okay, so record can also be initialized like that, list of record process DTO list equals new list of process DTO with a pair of circular braces. Now then a for each command. Now let's write a for each loop. Tab, so it should create a for each shell, for each var item in collection. And what is var? So this, item is C, common entity in common entities. For each var Z in common entities, we will initialize a process, new process class, okay, with an object P, which is a new process, an instance of the process class, and then P dot, it's not this, P dot ID actually. P dot ID equals C dot process ID. Common entity dot process ID and P process dot drone ID equals common entity dot drone ID, because we've already joined it. This process, this common entity it has come up as a consequence of joining the orders with the joining the process entities with the orders, okay, on these criteria, where A goes to A is A dot order ID and B is B dot ID, okay. So on the ID columns they are joined. So P dot ID equals common entity dot process ID, process dot drone ID equals common entity dot drone ID, equals common entity dot order ID. Now it is correctly guesstimated, C dot common entity dot order ID. So process dot order ID is equal to common entity dot order ID, and process dot status equals common entity dot status, and then process dot acquired date equals common entity dot acquired date after the join, as a result of the join. And then finally, to this process list, process DTO list, I will add this P. Common entity dot address and common entity dot quantity. So this is the final code. So for each var CE common entity in common entities, process P equals new process is initialized, and then process.id equals common entity dot process ID, process.drone ID equals common entity dot drone ID, and all these other conditions. Okay, and then process DTO list, to this process DTO list we have added this process P dot as DTO, because it should return a process DTO list. Okay, and then we finally return OK status code with process DTO list. Now let's complete the HTTP post. Post method for posting the data. So in the post method, I will pass grant order DTO. So grant order DTO. So what was this grant order DTO? That was a record. So if you quickly look into the definition, so this is a grant order DTO. It takes in drone ID, order ID, and the string status, and the status as a string. So var A goes to a.drone ID is equal to grant order DTO.drone ID and dot order ID. A dot order ID equals grant order DTO dot order ID. Okay. If process equals null, We are not going to return a bad request, but we have to create a new request, new process. Okay, so process equals this one is correct. Order ID equals grant order DTO dot order ID and drone ID equals grant order DTO dot drone ID. Status is grant order DTO dot status and acquired date. UTC now. And semicolon finally. And then outside this bracket it is await. Repository dot create async, call the create async method and pass the process. Okay, so it will create the process, asynchronously create a process. All right, so here it is, this process. So if process equals null, else if it is not null, process dot status equals grant order DTO dot status. And then await repository dot update async process and then return OK. And don't need the process over here because it is a post. It is getting posted. All right, that's all. So you can see that there are two methods as we just discussed. A get async. The get async fetches the process record from its local MongoDB database and also makes HTTP request to the first microservice to get all the orders. It then combines both these two and returns it as a list of process DTO. And the post async, this method creates a process record in the MongoDB database, and this method also updates the process record. Now we'll test this method too, so we'll have to run both the microservice, command center and process center in Visual Studio. Now we'll execute the microservice with our Swagger. That will come next. It's time now to check both the microservices and how process center is communicating with the command center microservice. So I have already run both the applications, and you can see that this is the process center application running with the Swagger open, and it's running on its old Swagger port 7291, as well as the command center, which is this is the command center. It is running on its own Swagger port 7196. So I would like to also show you that I have already run these two applications, this command center, and after running the application, I have run the Docker Compose up on my command shell, and that has created these two containers that we have already explained in the part 2 when we talked about the command center microservice, and the MongoExpress is running. This is a GUI, and this is the MongoDB server running on off the Docker container. So I again highly recommend for you to look into the first the previous part. There is a part 2 for even further descriptive explanation of these two containers. All right, so this is a GUI, so we'll see the GUI also in action soon. Now what we'll do is we'll switch over to this command center, and then we will see what are the orders, because this is the first microservice and we have created some orders. So I have already executed and we have got these two orders, ID, address, quantity, and created date. So I have got two IDs which will act as order ID on the process center application. So we'll note one of these IDs, say this one ID. Let's take this ID, copy it with Control C, because we'll be using this ID to get for the process center, the second microservice that we built in this lecture, to communicate with this microservice. Okay, so I have now switched over to process center, where we'll create a process like this, and if we create the try it out button, it is asking for, it requires a drone ID, an order ID, and a status. Okay, so what I will do is, for the order ID that I have copied from the command center, I will paste it over there. The ID for the command center is the order ID for the process center. Okay, so I will just paste it over here. And for drone ID, this is a fictitious ID, and I can keep the same ID, but I can also change. It's just a template for you. Okay, let us keep this drone ID as the same that is written for me already, and status is processing. So change the status as processing. And then execute. And before executing, let us copy this drone ID somewhere, because it will be required later on to fetch the record. So I copy this and then open a notepad. Notepad instance, and copy this drone ID over here. Okay, and then I will just put it somewhere in the taskbar, and then execute. All right, so I've executed. So it is showing success. So one or more validation occurs. Errors occurred. Okay, the JSON value could not be converted to process.infrastructure path 5 ordered. Okay, let's see. Hi there. No matter that the post actually showed some validation error, so I have just ignored that, and I have got this drone ID again, which was copied on my notepad, this value. So this value I have put on the get, okay, and executed, and it has come back with the correct order ID. So it has got the order ID and address, quantity, string. So that means this post method, the post was it was not necessary. It was, I mean, it was some sort of a warning, but it still executed the order, and it got this all this information like order ID, address, quantity, status, process ID, drone ID, acquired date, etc. Everything it has got. Okay, so it's working. So only thing is that I didn't get the status here. So let me try with another post. So let's get the other ID. So get back to the command center. And we have got these two IDs. So I will try with the other ID for which the address is 45 Wollaston Place, Flatbush, and I'll just copy this one. All right, and go back to the process center. Just close this and let us execute the different order ID. The second of the two orders on the command center. So here the order ID is this, and drone ID. Let's write a different drone ID. So I have copied a drone ID from the blog on my clipboard, and then let's write this other one, drone ID, as this one, and status is processing again. And then execute. This time it says that, there's just 200 success codes. It's all success. All right. So there is no validation error. So what we'll note, which we'll note this drone ID. This is already with my clipboard, and now I'll get the process get. I'll run the get verb. So I'll just change the new drone ID. With the new drone ID, execute, and here I get the status processing correctly. So there was some problem with the GUI ID, that's why it didn't take. So it took the order ID, the other order ID from the command center, which I can again show you. This is the order ID I took. Let me just try to magnify this one so you can see more visually. 9FFEAA18-ODDA, something like that. So this one, this is back to, let me go back to process center. So here you have got this one, 9FFEAA18. So it was the same ID that we actually chose, and here it is, order ID, and it's given processing. So I'm successfully shown you how to test it on Swagger. And here also one thing needs to be told, because that is very important, that first three fields, the order ID, which I've already discussed, address, quantity, these three fields are being extracted from the first microservice by the second microservice. Okay, so they are coming from the first microservice while the others are coming from the second microservice, these four other fields. The same method called post async of the process controller updates the process records too. If a record with the given drone ID and order ID is already in the database, then the record is updated. So we can also update the status of the record to completed. Okay, so we can create another post. So now let us change this status to completed, and then click on execute, and then we get another 200 success status. Okay, so you can execute again. It is already completed. Okay, status completed. It's passed over to this, and then let's see this 200 get over, and now get, if you execute this, now status is completed. All right, from processing to completed. So now one last thing that I wanted to show you again, like I did on the first occasion, is that MongoExpress, which is running on localhost 8081, in action again. So now here, if you look into this MongoExpress, I've got all these databases. So order database, and you can see the order collections. So you've got these two collection: ID, address, quantity, and created date. Okay, so this we have already seen on the Swagger, so it matches with the Swagger. And if you look into, this is order collection pizza items, and if you switch over to the other process, so you have got all this status databases, status size, storage size. But what we will be interested is in the collections. So these are the collection. So ID, order ID, drone ID, status, and completed. So last one I showed you from status processing to completed with this drone ID and this order ID. All right, and the one that came up with some validation error somehow, whatever it is, it's not something very important for me to now discuss at this stage. So its status was not changed to processing. So this is the drone ID which worked for me. All right, so thank you very much for being so patient throughout this journey of this tutorials. And if you like my tutorials, please subscribe to the channel and share it with your friends and put your comments